Welcome to the Databricks Skill Builder series. We're glad you're here.
Thanks everybody for joining today. We have a special guest, Grant Doyle. He is a solutions architect at Databricks, and he's going to talk to us about Lakebase.
Awesome. Thank you, Stephanie. Yep, I'm Grant. I'm on the Lakebase Embedded Product Lead group. So I do Lakebase conversations all day. And this conversation is really going to be around why Lakebase, why we think Lakebase fits in well to the enterprise and solves real challenges that both the warehousing and application development teams have been facing for several decades now at this point. So let's dive right in. And let's set the foundation to make sure that you understand the difference between analytical and transactional systems. So with analytical systems, this is what Databricks has been doing really well for a decade and a half. It is the OLAP systems. These primarily serve analytical purposes. So you commonly see questions like this of what were total sales by region, product, category, 2 years, and how does this compare to the same period as last year? If you see every word there in orange, those are columns. And one thing to note is that analytical systems are column-oriented. So doing things like the statements on the right is fairly difficult. When you need to insert a new record into a table, do quick lookups on particular records by ID, that's not best served in an analytical system that is columnar-oriented. That is best served in a transactional system that is row-oriented. And so we can see that for a lot of the transactional systems, think of your Postgres, SQL Server. These are very much, let's insert data and let's get data out as quickly as we can. All right, so let's dive into how answering particular questions is a bit different with these two different systems. Getting something like, what is a customer's risk profile, can be an easy question to answer if you've built out several gold tables that have different profiles for different customers, different criteria to assess risk. And with a simple query, you'd be able to ping your table and get back a list of customers that fall within a given profile. But if you're in an OLTP system, this can be a pretty difficult question to answer. Your application is most likely going to have complex logic that is baked in. Maybe it's pinging several different endpoints. It's doing a lot of computation on the fly. And it really introduces a lot of additional logic into an application when it shouldn't have to. This should be something where you hit a simple endpoint and get your data back. I'll edit some things here real quick. Okay. So patterns like this quickly become the bottleneck in any application. And what this means is that many teams avoid answering complex questions like this at all. Or they try to bridge the gap between these analytical type of questions into their application. And what it really boils down to and what it creates are complex pipelines that are brittle and are expensive. So teams have been trying to bridge this gap for years. And I kind of want to take you on a journey of how teams have done so, how the different systems have evolved, and why we think Lakebase can help alleviate a lot of this pain. All right, so bridging this gap is harder than it looks. We have a data warehousing team that is very analytical in nature, and they're typically answering questions for the business after events have occurred. It's very retroactive. Whereas the application development team is more operational, very concerned with what is happening here and now within the business as they host the applications that drive the business. Application development teams typically do a lot of custom development. They work in agile schedules, whereas the warehousing team may be non-agile and is buying a lot of the platforms to help build out their solutions. So let's take a look back at how these teams have kind of been shaped over the last couple of decades and what problems have arose throughout the different transformations. So phase one, think back to like the 1980s, maybe the 1990s, during the early days of databases, where IT owns everything. And this is typically just the transactional systems. They're deeply specialized with the database. It's complex, it's expensive, IT owns everything. all of the connections, all of the data, and it's very difficult for the business to get close to the databases and the value that is stored within inside of it. So business users recognize how complex all these systems are, how technical the IT staff is. And what this kind of boiled down to was the business being able to write tickets, hand them to IT, hoping IT can do the translation and get the business the insights or answer the questions that the business needs to make key decisions. And so the trouble is by the time that IT was able to deliver on particular asks, the business had often already changed, already moved on, or forgotten what their question even was. So IT felt like they couldn't serve the business in the best way possible, and the business was frustrated with IT because they couldn't get the answers to the questions that they needed. To solve this, we see a big emergence of OLAP systems. So those columnar data stores, those data warehouses, this is where things like Kimball's data model, dimensional modeling really started to get proliferated throughout all the enterprises. This typically happened in like the mid to late 2000s. And we saw a lot of enterprises rushing to re-architect all of their databases around this new idea. And this was good. The IT team was able to develop new skill sets, answer new questions, but it also came with some challenges. They had to establish new data teams. They did have to get upskilled on how to do particular things with these OLAP systems. And the business got a little bit of what they needed. They were able to answer more complex questions. Answers were coming in a little bit quicker. But the business was often getting reports and not really answers. And so by the time insights surfaced, the window to act on that was typically closed. Old problems kind of compounded again and again to where miscommunication got worse, and the business began asking more and more sophisticated questions that IT couldn't really translate into data requests. So getting data from those operational OLTP systems into the warehouse required really complex ETL pipelines that were brittle, expensive to maintain, and often owned by yet another team within IT. So we start to see the bifurcation of the two teams here, where we have an OLTP type team that is delivering the business applications, and the OLAP team, the data warehousing team, that is starting to serve the business more. And we see this evolve as we move into the next phase of the cloud. So by the late 2010s into the early 2020s, both teams start to mature in the cloud, but the gap between them hasn't really closed. IT has more modern tooling, but integrating with the OLTP systems still remains painful and very costly to operate. App dev had evolved too, but in the wrong direction for the business. There was complex business logic that got baked into the applications, more fragile data architectures. Maybe the service performance is degrading because of all the changes that occur within the database. And this causes the business to be frustrated with both teams. IT couldn't really get answers fast enough because the data took too long and cost too much to move. App dev couldn't ship features fast enough because there was this constantly altering and changing data model. And both teams are just trying to do their best, but still come up short of what the business actually needs. This is where we think Lakebase can really come in and make a big difference. What if data integration was a feature and not really a project? What if it was built into the platform and not bolted on as an afterthought? Both teams could have their data in a format that best suits their workload. Seamless connectivity between the two, low management, if not none, to operate that pipeline and allow both teams to service each other in the best way possible. And this is where we think Lakebase can really come in and bridge the gap between these two teams. So the warehousing team can still continue to work in Databricks Lakehouse with all the Delta tables, servicing their OLAP type use cases and getting the business key insights into what is happening. Meanwhile, the application development team and the software engineers can leverage the state-of-the-art Lakebase, which is the best-in-class Postgres offering, to drive all of their back-end applications, deliver value to the business. But now the two teams can work seamlessly together and start to deliver value for one another in a way that we haven't seen before. So the warehousing team can make their really valuable, think of those gold level data sets that answer complex questions. They can make those available to the application development team within their Lakebase instance. That means that answering complex questions in the application becomes a quick lookup into a table rather than pinging several different systems and having the application do all the hard work. This also means that the warehousing team gets key insights that is occurring within the transactional system that app dev is providing the business. Both teams get the data they need and they want in the format that is best for them to deliver value the quickest. So now that you see why Lakebase is valuable, I want to dive into some of the key features that we think separates Lakebase from the rest. I'll touch on these briefly here, and we'll kind of dive into each particular one. One of the key components of Lakebase, particularly with auto-scaling, is the ability to separate the compute and storage. Similar to what Databricks has done with Delta and Spark, we're doing here with Lakebase. We separated the compute and storage that enables for a lot of the cool features that you see here on this slide. We can set flexible compute nodes to allow our Lakebase instance to scale up and down as needed, and even the ability to scale to 0. We can branch the database. Think of like how you clone a code repository. You can do that with your database so that developers and agents can work on production data within an isolated environment and test their changes on valid data before they go to production. This also creates the really cool feature of bi-directional streaming of data, again, so that the different teams that have different data needs can get their data in either an OLAP or an OLTP format to best serve their workload. And of course, all this is governed by Unity Catalog. So I'll dive in and talk about auto-scaling a bit. Again, with that separation of compute and storage, we can scale up the compute up and down as much as we need to best service the workload. What this means is that you're only paying for the compute that is serving the workload. You're not paying for instances that are up and idle. So you can set the upper and lower bounds of your compute node. You can scale to 0, which is an awesome feature. We can scale up from 0 in a matter of a couple hundred milliseconds. And we can scale down, I think, as little as 1 minute. That's a range that you can set when you toggle the scale to 0 on. This is also instantly ready. So being able to scale down to 0 in a meaningful way, because you can quickly spin the database back up to service your users. The bi-directional streaming of data is something that I'm really excited about. You can take all of your Delta tables that are valuable to the business and sync those in a very managed, hands-off way to your Lakebase instances. This means that warehousing teams can begin to serve the more transactional type of workloads that deliver key value to the business. This is what we're calling the reverse ETL approach. So if you hear Delta to Lakebase, that is a reverse ETL approach. The forward ETL approach is taking the data that is within the Postgres tables and putting that into a Delta table. This is also a really cool feature that is very hands-off. All you need to do is run an alter statement against your table or the tables within the database, and it will automatically sync back to a Delta table in as little as 5 seconds. So again, all of this is very simple. It's very hands-off. You no longer need to replicate the data using custom, complex, and often costly solutions. And of course, all of this is governed by Unity Catalog. All of your bronze, silver, gold tables are governed within Unity Catalog, but you can also federate your Lakebase instance into Unity Catalog to ease some of the complex queries you may have across the operational and analytical data stores. You can also have the flexibility of Postgres and Databricks roles within your Lakebase instance. So if you're really familiar with Postgres and how the roles work there, you can still use those within Lakebase. You're not bound to just the Unity Catalog governance model. And of course, you get all the first-class compute that enables these workloads to run well and reliably on the Databricks platform. All right, so again, like going back to the separation of the compute and storage, one of the really cool things we get to do is database branching. This really lets you merge your changes with the database with confidence. So imagine being able to pull your production database, as all that valuable production data, that real data, and develop features against that data in an isolated environment without having to copy any data down to a lower environment. This is really awesome. It allows you to test on real data and merge changes with confidence. We see a lot of customers that are building in branching and testing into their CI/CD workflows to do last-minute validation before they push a change. And we also see a lot of agents that are able to take advantage of this branching methodology. Your agents can go create a branch, test changes, validate them, present them to you, the user, and you can merge to production with confidence. And that's really what we think the next phase 4 will be, is allowing safe development of your databases with agents, making sure that they can make changes, they can validate, and they can implement with confidence. So if you wanted to learn more about Lakebase, here are a few resources we'll put in the description. We're also going to have a few additional videos showing you how you can actually go through and set up all of these key features. Thanks.